to the next point.
Towards
We should ensure whatever we see is clear.
that means work is being done. We can see that it is in opposite direction. It is against. Good day, learners. Welcome to today's physics lesson on radio and television e-learning program of Ministry of Education, Kaduna State. Today we shall be looking at the topic, particle nature of matter 1. The outline is as follows. We have structure of matter, molecules, state of matter, then assignment. Structure of matter. First, we will look at the evidence of the particle nature of matter. Matter is made up of tiny, indivisible particles called atoms. We say they are indivisible, which means that they cannot be further broken down into smaller pieces again. And these atoms cannot be seen with the naked eyes. These atoms are constantly in a rapid motion according to the assumption of kinetic molecular theory of matter. Now, the experimental evidence of the particle nature of matter is the Brownian motion. We have other evidences which we are going to look at, about 3. And the first one we will consider is the Brownian motion. It was named after the biologist Robert Brown, who made the discovery in 1827. He observed tiny pollen grains suspended in water under a microscope. And he noticed that the tiny pollen grains moved about in a zigzag path. That means they move randomly in a disorderly manner, even though the water appeared to be perfectly still. These pollen grains were supposed to be knocked about by the vigorous motion of the water molecules. Another evidence, a second evidence we will look at, another evidence of the particle nature of matter was obtained from analysis of chemical reactions, which is called law of definite proportions. And it states that when 2 or more elements combine to form a compound, they always do so in the same proportions by weight. Now, for example, the compound water, H2O, is always formed by 2 parts of hydrogen and 16 parts of oxygen. These parts, they are according to the weight of these elements. Now, a third evidence is the process of diffusion. Now, if we place a few drops of liquid bromine at the bottom of a gas jar and then cover the top with a glass cover, after some time, the brown bromine vapor will be seen in the upper region of the gas jar, despite the fact that bromine vapor is much denser than air and should remain at the bottom of the jar. Now, the bromine water, after some time we say it will be seen at the upper region of that jar, though it is heavier than air, which means it is supposed to remain below, but it has moved, okay? It has moved to the upper region of this jar, showing us that, giving us an evidence of the particle nature of matter. Diffusion, or spreading out of the bromine, can be explained by assuming that liquid bromine is composed of particles and that the particles can move about easily. So the reason why we could see this bromine vapor at the upper region of this jar is because they can move, and they move easily, and that's which shows that they are particles in nature. Now here we have the diagram showing bromine vapor, which gradually spreads out to fill the whole jar. The first jar we have, this is the bromine water at the bottom of the jar, covered with a glass cover at the top. After some time, we can see the whole jar is covered with bromine water, which is colored with blue color. All this evidence is given that matter is composed of particles. They are indirect evidences. There is no direct evidence for the existence or to show the existence of these particles. Why? Because we cannot observe them. We cannot observe these particles even with the most powerful microscope. They cannot be observed. So they are just indirect evidences. B, we will now look at the simple atomic structure. Simple atomic structure. And we say an atom is the smallest indivisible particle of an element which can take part in a chemical change. Just like I've said before, we say the atoms, they are indivisible particles. Indivisible, that means they cannot be further subdivided or broken down into other particles. Now, the atom consists of two parts, and these two parts are held together by electric forces. The two parts are the nucleus and the electrons. So the two parts of an atom, we have nucleus and the electrons. So here we have the diagram showing the structure of an atom. Here in the center, we have the nucleus with some particles. We can see that some are denoted plus and some without any sign. Then we have these two orbits with electrons on them, which are the second parts of the structure of an atom. Now, in the middle, we have proton, which are the positively charged particles. Then we have the neutrons without any charge. Now, the protons and the neutrons form the nucleus of the atom. Then we have the electrons surrounding the nucleus of the atom. So we say the nucleus is the central part of the atom, and it is heavy, or we can say it is massive, and it consists of protons and neutrons, just like I have said before, that the nucleus consists of protons and neutrons. So we said the protons are positively charged, while the neutrons are neutral. They are neutral. That is to say, they do not carry any charge. They are neither negatively charged nor positively charged. And we have the second part which are the electrons. So we said the electrons which form this second part of the atom, they are very light compared to the protons. They are light and they are about 1 over 1,840 of the mass of a proton. That's how light they can be compared to the heaviness of the proton. So we said the electrons, they are negatively charged. They are negatively charged particles. And the lightness of the electrons, their light nature makes it easy for these electrons to be transferred when two materials are made to rub against or to move against each other. These electrons can easily be transferred. Why? We said because they are light, they are not heavy. And we said the electrons surround the nucleus in an orbit, and they are held together by the electrostatic force of attraction. Okay? So the electrons, they surround the nucleus in an orbit, and they are held together by the electrostatic force of attraction. Now, in a neutral atom, that is an atom that is not charged, whether positively or negatively. So in a neutral atom, the total number of protons in the nucleus of the atom, the total number of the protons in the nucleus of the atom is equal to the total number of electrons surrounding the nucleus of the atom. For example, let's say we have an element with atomic number 11, which means there are 11 protons in the nucleus of that atom, and also 11 electrons surrounding the nucleus of that atom. So, which means we have 11 positive charges in the nucleus of the atom and 11 negative charges surrounding the nucleus of the atom. So plus 11 and minus 11 will cancel out, so there will be no charge, and we say that that atom is neutral. Now we look at molecules, and we say most substances cannot exist by themselves as individual atoms. Their atoms combine with themselves or with the atoms of other substances to form molecules. Okay? So we said again that their atoms can combine with themselves or with the atoms of other substances to form molecules. Now, a molecule is the smallest particle of a substance which can have a separate existence and still retain the properties of that substance. The molecules of any substance are identical. The molecules of any particular substance, they are identical. Now they have the same structure, the same mass, and the same mechanical and electrical properties. A molecule may be made up of similar atoms of the same element or different atoms of two or more elements. For example, a molecule of hydrogen, H2, is made up of two atoms of hydrogen. We can see two atoms of hydrogen combining together to form hydrogen molecule H2. Then hydrogen, yes, molecule H2. Two atoms of that hydrogen combine together. Then for water molecule H2O is a combination of two atoms of hydrogen and one atom of oxygen. And then we have another example, a molecule of sodium chloride is a combination of one atom of sodium and one atom of chlorine that combine together to form sodium chloride. We look at the size of a molecule. The size of a molecule is extremely small, and it is of the order of 10 to the power minus 9 to 10 to the power minus 10 meter, or 10 to the power minus 7 to 10 to the power minus 8 centimeter. As a result of this small size, 1 gram of an element contains very millions of molecules. Now, to estimate the size of a molecule, the experiment is as follows. First, pour clean water into a shallow dish or tray and sprinkle some lycopodium powder lightly on the water. Then, using a graduated pipette, take a small volume of oil, example, an olive oil. 3, drop a very small quantity of the oil onto the water in the dish. Volume of the oil drop is equal to the initial pipette reading minus final pipette reading. That is to know the volume of the oil that has been dropped, okay, into that mixture of lycopodium powder and the water. You subtract the final pipette reading from the initial pipette reading, and then you get the volume. Now allow the oil to spread, pushing the lycopodium powder outwards and forming a clear, thin film of oil on top of the water surface. Measure the diameter of the oil patch with a rule. The oil drop is spherical in shape, while the oil film or patch is cylindrical in shape. Let the thickness or height of oil film or patch be h. Now, volume of oil drop is equal to volume of oil patch. Now, the volume of oil drop, the formula is 4 pi r1 cube over 3 to be equals to the volume of oil patch is pi r2 squared h. From the above equation, the thickness h of the oil film can be calculated, and we have h. If we make h the subject of the formula, we have h to be equals to volume of oil drop over area of oil film. The thickness h of an oil film is taken as the size of a molecule. Example 1. A small drop of oil with a diameter of 0.15 millimeter is dropped onto a dust-covered water surface. The resulting cylindrical patch of oil has a diameter of 20 centimeters. Calculate the maximum size of an oil molecule. Solution. We have in our data diameter of oil drop, we call it D1, which is 0.15 millimeter. If we convert to meter, we will have D1 to be equals to 0.00015 meter, or 15 times 10 raised to the power minus 5 meter. And radius of oil drop, R1, will be equals to the diameter divided by 2, because we know that radius is half of diameter. So we now have 0.00015 divided by 2, and we have R1 to be equals to 0.00015 0.0075 meter, or 7.5 times 10 raised to power minus 5 meter. We have diameter of oil patch D2 to be equals to 20 centimeter. Converting to meter, we will have 0.2 meter. Now, radius of oil patch R2 will be the diameter of the oil patch divided by 2, which is 0.2 divided by 2, and that gives us 0.1 meter. So volume of oil drop V1, applying the formula 4/3 pi R1 cube. V1 will be equals to 4/3 times 22/7 times 7.5 times 10 raised to power minus 5 all raised to power 3. And we will have V1 to be equals to 4/3 times 22/7 times 421.875 times 10 raised to power minus 15. And we have V1 to be equals to 1767.86 times 10 raised to power minus 15 meters cube. Okay. Area of oil patch A is equals to pi R2 squared, and A is equals to 22/7 times brackets 0.1 squared. So we have A to be equals to 22/7 times 0.01. Therefore, our area A is equals to 3.142 times 10 raised to power minus 2 meter squared. So thickness of oil patch H is equals to volume of oil drop over area of oil patch. So we have H to be equals to 1767.86 times 10 raised to power minus 15 divided by 3.142 times 10 raised to power minus 2, and we have H, the thickness, to be equals to 0.6 times 10 raised to power minus 10 meter. Therefore, thickness of oil film is equals to maximum size of an oil molecule, which is 0.6 times 10 raised to power minus 10 meter. With this, we have come to the end of the lesson for today. I will call on my colleague, Mr. Napoleon Kure, to come and summarize and give you assignment. Thank you. See you in our next class. I remain Hassan Buki.
Hello, learners. From what you have heard from my colleague, I believe he's clearly understood on the particle nature of matter part 1. He has been able to let us know that there are evidences that show that matter is made up of particles. The Brownian motion, you have the law of definite proportion, you have also diffusion. And beyond that, he went on to explain what the molecule is and how the size of a molecule generally can be determined using the oil film drop experiment. And with this, I want to give you a work to take yourself, be busy at home with as you prepare for your exams. Assignment number 1. Briefly explain the 3 evidences of the particle nature of matter. 2. With the aid of a diagram, describe a simple atomic structure. 3. A drop of oil of volume 10 times 10 to the power minus 10 meter cube sprays out on water to make a cylindrical film of radius 10 to the power minus 1 meter. What is the thickness of the film? Assignment again, number 1. Briefly explain the three evidences of the particle nature of matter. Number 2, with the aid of a diagram, describe a simple atomic structure. 3, a drop of oil of volume 10 times 10 to the power minus 10 cubic meter sprays out on water to make a cylindrical film or radius 10 to the power minus 1 meter. What is the thickness of the film? We have some of the references you can consult and other ones beyond that. 1, New School Physics by M.W. Anyakoha. 2, All-Inclusive Calculations in Physics by Solomon Dauda Yako. 3, Senior Secondary School Physics by P.N. Okeke and M.W. Anyakoha. With this, more problem to solve as you prepare for a WAEC and for your exams and any other one that come your way. Wish you the best, and our contacts are Hassan Buki, 080 65 50 4346, Napoleon Kure, 080 3636 2105. You are advised to stay safe and keep learning. Wish you the best. God bless you. We see you in our lake lesson. Thank you. I remain Napoleon Kure.